Hi, if you're watching this video, that means that I have successfully managed to turn this mini fridge here into a cheese cave. A little history on my mini fridge here. I bought this mini fridge when I moved into my first apartment. This was the first time that I was living on my own. No roommates, no family supporting me. It was just me and my paycheck paying my rent, and I was becoming like a full-fledged adult who could take care of himself. When I bought this mini fridge, I was under the impression that I was gonna have parties and gatherings at my apartment all the time. I was gonna be bringing my friends, all my friends from all my circles together every weekend, and we were gonna be drinking like beer and mixers and chilled liquor and all kinds of stuff out of this fridge, and we were gonna have a good old time. And then I proceeded to not have any parties at my place ever. Well, okay, maybe I had two. Now, to my credit, this thing actually did see some use in my apartment. It was like halfway filled with citrus and mixers and soda and all that kind of stuff. And occasionally, I would actually use the stuff inside of it to make drinks. But then I had the good fortune of being able to move into my house, where I have a fridge that is huge, way too big for just me. It has more than enough space for anything I'll ever be able to put into it. And this mini fridge here has been sitting in my living room completely empty, unplugged, for almost 4 years now. The thing is, I am actually a bit sentimental about this thing. I bought it as a testament to my self-sufficiency. And so when it came time to figure out what to do with it, I didn't want to get rid of it. I wanted to figure out something else. A little Googling and I found a DIY community of home brewers and home cheesemakers who have converted mini fridges into cheese caves. Before I continue further, I do want to give a shout out to the YouTube channel Technology Connections. Pretty much this entire video has been inspired by a video that Alec, the host of that show, made, where he hacked his mini fridge that was really, really awesome, but also really problematic into something that was much better. I mean, his whole video is the only reason why I know something like this is possible. So let's talk about what exactly is a cheese cave. A cheese cave in real life with dairy producers is sometimes an actual cave, or in other cases, it's a converted mine where cheese is stored in massive amounts. And these gigantic facilities have three things going for them. They have good temperature, good humidity, and good ventilation. Cheese caves need to hit a temperature between 45 degrees and 60 degrees Fahrenheit. Refrigerators, like this one, and pretty much any refrigerator used in a kitchen, is meant to store produce and prepared food in an environment that is going to be safe to be reheated or consumed later. And those temperature ranges on those fridges is usually going from 35 to 42 degrees Fahrenheit. So already you can see that's too cold for cheese. So how can we solve this problem? Well, the first thing we need to do is educate ourselves a little bit into how refrigerators work. The first component of a refrigerator is this thing inside here, the thermostat. This thing is going to measure the ambient temperature of the inside of the fridge. If it detects that things are getting too warm, it's going to flip a switch that will run power to the next component. That next device is the compressor, which is on the back of the fridge. This device compresses refrigerant into a liquid and prepares it to be circulated through the walls of the interior of the fridge. And that's the last component, the refrigerant itself. That super cold liquid is going to circulate through the walls of the inside of the fridge and start to chill everything down. Once the thermostat inside the fridge has detected that things have chilled down enough, it's going to flip its switch off, which is going to cut power to the compressor, and the fridge is going to go dormant. And then when things heat back up, the cycle begins again. Okay, so now we're a little bit smarter about how refrigerators work, but we still have a problem. How are we going to make this thing not go so cold? Well, the major culprit in this thing being too cold is the thermostat. That thing has a temperature range between 35 degrees and 42 degrees with the little knob inside of it. And it's pretty much impossible to make that thing read any temperature beyond that. But lucky for us, we can wire our way around it. On the back of the fridge is a schematic, and you can see on that schematic that power goes from the thermostat to the compressor over a red wire. We can cut that red wire and securely tape the end that's still connected to the thermostat so it's safe, and onto the other end, we can graft a new connection. And that connection will go into this little thing. This is a temperature sensor microcontroller. It's basically a thermostat, but it's a thermostat that we can completely control. We can set exactly what target temperature we want, and we can even set what temperature differential we want. It's really cool. We can use this to send power to our compressor when this thing says that things are too warm. And likewise, we can stop running our compressor when this thing that we control says it's cold enough. This has an end right here that plugs into our little controller. This is the temperature sensor. What I'm hoping I can do is I can just run this long wire through the door of the fridge and close it, and I'm hoping that the door can still make a good seal. If it does, great. Most of the magic in this process is going to come from this extension cord here, which we're going to snip off the ends and then break this down. I think that'll work. Okay, easy. And then we'll do the same thing to the other side. So I've stripped off some of this, and you can see here we have 3 wires. We have a green, a black, and a white. I need to remove all of these wires from this entire casing. So this is going to take a while. So as you can see here with this and the eviscerated remains of the casing, I've taken them all out. Now let's go ahead and cut them into strips. All right, so I've cut the wires into about strips this length. For this experiment, I believe we're going to need 3 black wires, 2 white wires, and 1 green wire that we may or may not use. Now let's go ahead and strip the covering of each of these individual wires, maybe about 1/4 to 1/2 inch down on both sides. All right, so we have stripped our wires. We have to start connecting these to actual components. For this part of the process, I was able to enlist the help of my friends Derek and Allison, both of whom are much more experienced at hacking electronics than I am. Allison, you're making sure that I don't kill myself, right?
Correct.
Okay, thank you. I appreciate that. We have our microcontroller. It is powered up. It is shooting for a target of 50 degrees Fahrenheit, so currently it is running the fridge. And you can hear it, hopefully, running now. That's the compressor that is currently going. My friends Derek and Allison helped me do a great job. The wiring on this was perfectly good. Down here, the plan mostly went like how I expected, but they thankfully helped me reuse some of the existing wiring in the fridge to where I actually only need to use one of the wires, the white wires that we have. Everything looks and sounds great. So yeah, I'm just gonna sit here and watch to see this temperature hopefully hit 50 degrees, and when it does, the fridge should stop. Oh, and just to be clear with everyone watching, I know there are simpler ways to do what I'm trying to do, but I'm extra. Sometimes in really dumb and stupid ways, but in ways that I hope are entertaining for people to watch. Now comes the next problem, humidity. Cheese caves need a target humidity between 75% and 90%, which is really humid. And refrigeration and humidity don't really mix together very well. Now, I've seen people try to solve this problem by putting cups of water inside the fridge, or like a tray, like a baking tray of water inside the fridge, but I don't like something like that because I can't control how much humidity is in it. I need something that allows me to really target those perfect percentages. And so we're gonna solve that problem with this thing right here. This is a reptile cage humidifier, a fog machine that pumps in water vapor through this hose into what would normally be a cage for, I don't know, a snake, a iguana, bearded dragon, I don't know. But the point is, this thing basically adds humidity over this long tube. But obviously, you can see there's already a problem. This is not going to fit through the door. There's no way the door is going to be able to close on this thing. So what are we going to do? Well, we have to drill a hole into the fridge. And that has another hazard. Liquid refrigerant, like the kind in this fridge, is flammable or toxic, maybe both. And it would be incredibly bad if we drilled a hole into this fridge and ruptured a refrigerant line. But there is one place where refrigerant is pretty much guaranteed not to be running. once again, the door. I'm gonna drill a hole through this door and run this tube inside of it. So with our fridge under good temperature control, let's talk about this. I made a hole in this, and then I taped it over with a piece of cardboard and some duct tape. So I need to figure out how I'm gonna get this tube through here, and I have a plan. First things first, I'm gonna take this cocktail skewer. It's long and sharp, and you can see that the hole is right here. I'm gonna take this cocktail skewer, and I'm gonna try and poke a hole directly in the center through the door. This is gonna take some maneuvering. Let's see, yes, we're going through the other side. Now I'm gonna go ahead, take it out. Now, I have my drill, and it has a hole saw. This hole saw is slightly smaller than the hole saw I used to make the original hole. So let's go ahead and drill straight through that. Cool, that was easy. This hole that I have now made is slightly smaller than this, but that's good because if we can, we can now get this hose all the way through the door, but it has a much tighter seal with the cardboard now, and I can do my best to duct tape around this and make a really, really good seal. Here's the thing about this humidifier. It's controlled by a hardware switch that you see right here, right? If I turn it this way, it turns on. When I turn it this way, it turns off. If I keep it this way and I remove power from this, it will obviously turn off. But if I bring power back into this, it will turn back on, and that's where this thing comes in handy. This is a humidity-controlled power outlet. This is a humidity sensor right here, and this can also go through the seal of the door and measure the humidity inside the fridge. If it gets too low, it will cause this thing to turn power to this on, and my humidifier will be plugged into this. When the humidity has reached a sufficient amount, this will turn power off to this outlet, and my humidifier will turn off. I'm gonna have like 3 or 4 different things coming out of the door of this fridge by the time I'm done. And then lastly, let's talk about ventilation. That's probably the easiest thing. I have a fan here, and it has a power outlet, and the cord will go through the door, and this thing will go kind of positioned facing up somewhere on the inside of my fridge, and it's just gonna continuously blow air around. Okay, so let's say that everything in this crazy plan actually goes well. The first thing I'm gonna do is I'm going to run a test. I'm gonna run this fridge for about 2 or 3 days and see if it can achieve stable temperature, stable humidity, and ventilation. Well, I think that'll kind of just work itself out. Now, I am hacking electrical components in this whole process, and I have a dog who stays in my house often. I am responsible for his safety. He is basically like my child. And I'm not taking any chances. So this fridge is gonna be here in my garage, and I'm going to mount a smoke detector in my garage above my fridge. Now, normally this would not be a great idea. Smoke detectors don't really do well in garages. There's too many kind of ambient factors at play here that could cause false alarms. But I have a loophole. My garage door opener has a camera on it, and if I position my fridge in view, I can see whether or not it's actually on fire if the smoke alarm goes off and I'm not home. The smoke alarm I have is thankfully connected to my security system, so I should be getting a phone call and I should be able to verify. I also don't want to file on my insurance claims that I burned my house down because I was trying to age cheese. And then, if we are lucky enough to get to that point, then we're gonna try and age a cheese. It'll be a simple recipe that goes for maybe 5 or 6 weeks. We just need to see if the process can work. All right, y'all, so let me go ahead and show you the final build. Right here at the front, we've got the humidifier, and it's got the hose running all the way into the door. One finicky thing about this setup is that this hose that you see here, at no point in this entire journey can it be allowed to sag down and create a U shape. The reason why that can't happen is because if that happens, the water vapor that comes out of here will condense into liquid water. it'll collect in that U-shaped sag, and it'll actually push it down even further. And then that little sag point will become a choke point because there's no water vapor that can get through that puddle of water and into the rest of the hose and into the fridge. So every couple of days, I've just been checking on this hose, making sure that it's not sagging down at any point. You can see right here that it follows a pretty straight line coming from the fridge all the way back down. So my hope is that if any condensation happens here, that liquid water will just trickle down, come back into the humidifier, and then turn back into vapor when it's in here. Let's go ahead and open up the door. All right, so that's where the water vapor is going to come out. And then this is where I decided to place the humidity sensor. This is the best spot for it. It is far enough away from the fan, from the temperature sensor, and from the evaporator to where I think it's getting good and accurate readings while not interfering or being interfered with by any of these things. This is where I decided to put the fan. This fan is blowing air against this back wall here, and this wall is slanted slightly upward. So my hope is that the air will come here, bounce off this, go up, gather around the evaporator section, which is super cold, and so that cold air will sink back down, go back into the fan, and then we'll just have a circulating system. This is new. This is a big Tupperware container full of water. Now, when I started this project, you might remember me saying that I didn't want to try to add humidity using cups of water or any reservoirs of water. And that's still true. This thing isn't so much here to add humidity to the fridge. It's more to stabilize the humidity and the temperature. What do I mean by that? Well, water has better thermal mass than air. So by replacing some of the air in this fridge with water, this will hopefully stay a little bit cooler for longer and keep the fridge from running as often. The second thing that this helps with is that when a refrigeration cycle kicks on for this whole machine, the humidity inside drops like a rock. It will go from 85 to 35. And that's with the humidifier running, right? The refrigeration cycle is too strong for the humidifier. This thing, despite trying to fight back against the dropping humidity, just can't win. So that humidity will drop way down, and then the humidifier takes forever to kick it back up. And we're just having two big swings there. Like the swings are too big to allow me to age the cheese properly. This, however, it slows down how quickly the humidity drops when this thing goes into refrigeration. And so with this inside, the humidifier can actually fight back against the dropping humidity, and it can actually win. And so now, with this big Tupperware container of water, the humidity will go from 85 to 78 or so. By that point, the humidifier has detected that things are not humid enough, and it'll kick on, and it'll actually bring it back up to 85, even with this thing running in a refrigeration cycle. So we have target humidity basically 100% of the time. It's really awesome. Some other things that are different, these are some wire shelves that I put in here. There were originally glass shelves in this fridge, but there was no way that the airflow was going to be able to get into the cheese with those glass shelves here. So I, as you can see, have done a little bit of hacking. These were originally legs that were downward. I bent them outward, I cut them down, and I created my own DIY wire shelves. This thing here is a little basket with a plastic covering. The evaporator, which this is the unit of the fridge that gets super cold and basically allows this whole thing to be a fridge. Condensation will gather underneath here, and it'll drip down onto the wheel of cheese. So I just put this basket and this plastic in here to protect whatever wheel of cheese is inside of here and keep it dry. There's my temperature sensor, kind of sagging down a bit, but it's in a good spot, and so far I haven't noticed any problems with it. And of course, that's plugged into this thing. I believe I have this set up to go to a max temperature of 56 and then stop running a refrigeration cycle at 53. Finally, the last thing about this setup is I need to open the door a little bit more. Okay, so this is the evaporator, right? Like I said, this is the unit that gets super cold and allows this entire thing to be a refrigerator, right? This thing, I mean, when I say it gets super cold, I mean it gets to below freezing, right? The cold air from that super cold freezing unit will sink down and make this into cheese cave temperatures, right? But this thing is gonna be super duper cold. And what happens is that because this is such a humid machine, condensation will gather inside this drip tray under the evaporator. And every 3 days, this thing gets pretty full. And I have to pull it out, and I have to dump it out, and then I have to put it back in and fight with it a little bit, fit it back under there. And it's annoying. It's probably the one thing about this setup that is keeping this entire thing from being a set it and forget it system. That being said, I think I could try to engineer some type of, like, I don't know, drain pipe to come down this back wall. And if you look down here, I don't know if you can see it. Oh, I don't know if you can see it. There is actually, oh, here. Let me see if I can get in there. Okay. So that's a little divot inside the fridge. I am almost positive that thing is supposed to be a hole, like straight up, like a drilled hole going down for water drainage from the top. It's not actually, there's not a hole there. I think it's kind of optional for this mini fridge, but I could potentially try to like engineer a drainage system and have like the water come down and collect down there, go through that hole, and then maybe drain out the back of the fridge through some kind of bucket. But all in all, this thing, I'll go ahead and maybe turn this camera around. You can see me. All in all, this thing is able, oh, my finger's in the way. All in all, this thing has been able to maintain target temperature and humidity 100% of the time. It's not the most energy efficient machine, but then again, I don't think it's pulling that many watts anyway. So for someone like me who has money to throw around for these crazy projects, I think it's okay. So with all this done and out of the way, let's actually get to the part where we make cheese. All right, so first thing we're gonna do is take 2 gallons of milk and pour it into a stock pot, and we're gonna heat that up to 88 degrees Fahrenheit. Midway through heating, we're gonna add a 1/4 teaspoon of calcium chloride since we're using pasteurized milk. Once things are up to temp, we're gonna add a 1/2 teaspoon of annatto coloring. This is gonna give our final product an orange color. And then things are gonna get really complicated because temperatures have to remain stable for a long time. So I took this container and I filled it full of water and I put my stock pot in there and I used my sous vide machine to maintain a very stable temperature of 88 degrees Fahrenheit. With that in place, we can add our culture. I'm using mesophilic starter. The recipe says to add 3/4 of 1 single packet. We sprinkle that in and we stir it up. With the culture stirred in, it's now time to add a 1/2 teaspoon of animal rennet. I like to add the rennet and start stirring, count to 20 seconds, and then cover the stock pot with a lid and let the cheese curds form. After 30 minutes, the cheese should start to come together, and now we have to slice it with a curd knife. We're gonna make cross-hatch cuts. Then we need to start stirring things very slowly, and you can see here from this video footage, the curds are starting to come together quite nicely. At this point, we're gonna turn up the heat to 105 degrees Fahrenheit as we stir the cheese every 5 minutes for the next 35 to 45 minutes. After that point, the curds should really start to come together. They should be in tiny, small clumps, and they should be very solid. But we're not done yet. We still need to let this cheese cook at this temperature for about 1.5 hours. Every 15 minutes, we're gonna stir the curds, and we're gonna remove 2 pints of whey from the stock pot, and then we're just gonna repeat the process again and again and again until 1.5 hours has gone by. After that, we can take our stock pot away and drain our curds from our whey. Our curds will drain for 30 minutes, then get salted, and then we're gonna put them in the cheese press. We're gonna start our cheese press at 20 pounds, and that's really gonna start squeezing the whey from the curds, and we're gonna keep it here for 1 hour. After that, we're gonna increase the pressure to 50 pounds, and we're gonna do that for 1 more hour, and then we're gonna take the cheese out, turn it, put it back in the cheese press, and squeeze it down at 70 pounds for 24 hours. After 24 hours, our cheese wheel has come together quite nicely. You can see there's some cracks and crevices, and at first it didn't seem like a problem, but then after the cheese dried out, those cracks and crevices got bigger and I had to do something about it. So I used a saltwater solution and I wet the cheese, and I used a butter knife to scrape off some shavings from the outside of the cheese. I turned this into a thick paste, and then I used it to fill in as many of the cracks as I possibly could. After letting that dry to a good amount, it's now time to melt down a whole block of wax. Once I got things down to a liquid, I covered our cheese wheel in 3 coats of clear wax, and then I was finally able to put it inside our cheese cave so that it could age. All right, so here is the cheese. It went into the cave on February 27th. Today is April, hey, it's 420. 53 days, so divide that by 7, a little over 7 weeks. So a little bit longer than expected, and everything for the most part went pretty well. I did notice mold growth 2 times. I caught it early, and so all I had to do was take a very small measuring spoon and just scrape it off, get the wax going, cover it back up, put it back in the fridge. So far, everything seems to be good. Now, we're gonna cut this thing open, and we're gonna see whether or not mold growth has happened inside the cheese, and it just hasn't appeared on the outside. That's kind of what I'm worried about the most. What I'm also worried about is there is a particular kind of bacteria that can grow, I'm not sure the name right now, but it is very harmful. If I see lots of little holes inside the cheese, it's very characteristic. That means that things have probably gone bad and I'm not gonna be able to eat this thing. Oh, this is dense. Here we go. That's what it looks like. I think this looks good. There are holes inside the cheese. Here, let me get my, there are small holes in the cheese, but this is not the characteristic pattern of that particular bad bacteria growth that I was talking about. You would see a lot more air pockets in the middle. This just looks like cheese that didn't quite knit together properly. That's just a fancy way of saying that the cheese, the curds, didn't quite fully come together as one mass. So we have a couple of air pockets where there was some air, but no mold growth inside, nothing. This whole experiment has gone much better than I could have ever hoped. Now, I say that, I have not yet eaten any of this cheese. I gotta scrape the wax off. That might be pretty easy to do, because I think I just need to take the wax and then slowly peel it off. Ooh, this cheese does smell really good. It smells like a really good cheddar. Let's see whether or not it's actually pleasant to taste. It's definitely sharp. It's sharp. I think it might be lacking in a little bit of salt. That's a note for next time. But it tastes like not an extra sharp cheddar, but a sharp cheddar, a mild cheddar. I'm sure that I could serve this alongside a very salty dish, and that would make up for the lack of salt here. Is it mind-blowingly good for my first attempt? No. But is it successfully edible cheese that could potentially be used in a recipe? That's the other thing too. I could mix this with another type of cheese, make mac and cheese with this. I actually could make mac and cheese with this, and I think it would actually be quite good. So, y'all, that is the end of this video and this incredibly crazy long experiment that has thankfully ended in success. If you liked what you've seen so far, please leave a like, comment, subscribe, and with all that said, until we see each other again, go cook something amazing, and I will see you next time.